Okay, so this is my first time trying Camtasia software with the notebook software, so bear with me a little bit. We learned about medians of a triangle and altitudes of a triangle, and just like angle bisectors and just like perpendicular bisectors, medians and altitudes have a point of concurrency as well. Kind of buried in your book, if you're doing this from your book, is the fact that the name of the point where the medians meet is called the centroid. And so this point P here would be the centroid. How do I know that? Because I can see that E is a midpoint by the tick marks. I can see that F is a midpoint, and I can see that D is a midpoint, and they're all connected to the vertices. So point P is the centroid of the circle. It's where all three medians meet. One nice thing about centroids is that the entire length of the median is equal to 2/3 the longer distance. So, for example, AP is 2/3 the whole thing, AE. So that you can know all sorts of things. If I were to give you that PE was 3, for example, then this is 3, that's 1/3, and this is 6, that's 2/3, and then the whole thing is 9. Or let's say I were to tell you that BF, the whole thing, was 15 units. Well, 2/3 of 15 is 10, so this section BP here would be 10, and this section PF would be 5. So you'll see some of those in your practice problems. The important part to get in your notes would be probably the sketch, the name that this is a centroid, and at least one of these examples of how AP is equal to 2/3 of the measure of segment AE, for example. Now, I talked about altitudes last time, and I drew in a picture like this, but I neglected to mention that, of course, if you have an obtuse triangle, some of the altitudes are going to be outside the triangle. If you had a right triangle, 2 of the altitudes are the legs, and so there are some special cases. So you don't have to draw that, but that'll help you to envision why, when we go for the concurrency of altitudes, if you look here, we have an obtuse triangle ABC. The concurrency point, which is called the orthocenter, that would be a really good important thing to get in your notes. The book kind of buries that term. So the orthocenter is where the altitudes meet. And when you first draw the altitudes, you might think they don't meet. But of course, if you extend this altitude and extend all the altitudes, they will always meet at one point, sometimes inside the triangle, sometimes outside the triangle, sometimes on the triangle. In fact, for a right triangle, it's the vertex of the right angle. But there you have it. Here's a good picture of where the orthocenters are. In an acute triangle, it's inside. There's point P there. In a right triangle, it's, as I said, the vertex of the right angle. And then in an obtuse triangle, it's going to be outside, like our example. Okay.